Hello, my name is Russell Malley. I teach anatomy and physiology here at Gavilan College. And this is a demonstration of a sheep heart dissection. I'll first go over some of the structures you can see using the model here of the heart, and then we'll go over them and show them on real sheep hearts and show you several ways to dissect a heart to show these structures both internally and externally. This section I'm going to go over structures to see when you get your hearts, external structures, and go over the protocol for ways to dissect the heart so you can see some of the internal structures. So this here is a model of a heart. Now this is a model of a human heart. Sheep hearts are very similar, so you'll see them very similar. Okay, the size for the sheep heart is also about the same. Your human heart is about the same size as your fist. So you can see this model is about the same size for my heart. You want to be able to orient the heart so you know the anterior front part versus the posterior. This view you're seeing here, this is an anterior view. This is as if it were in your heart facing out, in your body facing out. The heart has 4 chambers. There are 2 upper chambers and 2 lower chambers. The upper chambers, you can see evidence of them here. These are the atria. There is a right and a left atria. Blood comes back from the body into the heart at the right atrium. And blood comes back from the lungs and re-enters the heart at the left atrium. Each has a little flap of tissue. This is muscle tissue. These are called the auricles. There's a right auricle and a left auricle. The muscle structure is a little different in that, and when we see inside the heart, you'll see how that goes. Below, we have the 2 inferior chambers of the heart. These are the ventricles. These are the ones that pump the hardest in the heart. You have a right and a left. The right ventricle pumps blood to the lungs. The left ventricle pumps blood throughout the body. Each has a large blood vessel attached to it, each of the ventricles. In the front here, this blue part, this is the pulmonary trunk. This is the blood vessel that takes the blood from the right ventricle to the lungs. From the left ventricle, we have attached the aorta. It is pretty much in the center if you're looking down. And this sends blood throughout the body. Okay. Now, you'll see there's a little space, a little indentation right here between the 2 ventricles. This is the interventricular sulcus. And it's a spot where the blood vessels that supply the heart with blood run down in here. You can see here. Those will be a little hard to see when we go into the sheep heart. You see there's another one with blood vessels running down this direction. Okay, now we'll move and look at the back of the heart. You can see the atria a little better from the posterior view. This is now the right side and the left side. Blood comes back through 4 pulmonary veins back from the lungs. There are 2 right and 2 left, so 2 come back from each side. In the sheep hearts, these are often cut off, and they're very hard to see if they're there. Okay. The 2 blood vessels, large blood vessels bringing blood back to the heart from around the body are the superior vena cava and the inferior vena cava, where my fingers are. Okay, this brings blood back from the lower body. This brings back blood to the heart from the upper body. Again, this may be cut off, and you may not be able to see these 2 blood vessels at all. It may be cut open like this. Okay, now you can also see evidence of where in the back, there is another septum, sulcus here, where the 2 ventricles meet. And there's a little indentation there, and you can also see it where there's blood vessels that run through there. This is the posterior interventricular sulcus. There's also another area where the ventricles and the atria meet. It's also a spot where blood vessels run on the outside. There's a very large vein here. This section is called the coronary sinus, and a sinus is just a special type of vein. And here we have it running here in the back. Should be able to find that on the sheep hearts. When you do get your heart, you're probably going to want to poke around, orient it. Now, poke, especially useful is poking the ventricles. You can get an idea of the thickness of the walls of the ventricles by doing that. And you should see that the left side, the walls are firmer, indicating thicker walls, and thinner walls, less resistance when you poke on the right ventricle. Okay, now that gets us to how we're going to cut. There are two ways to do this. We can make small incisions here up to about the septum here, the sulcus on the outside, across here, and cut a small window. And we can do another window on the right side here. All right. The other way to do this is just to make one large cut all the way around at about the border between the ventricle and the atrium, all the way across like this. Now this model actually has a cut like that, and then cut down this way, and we can open it up. And we can see some of the internal structure. So I'm going to just open up this model, and we can see the internal structures. All right. There are four valves in the heart, and they're put into two different types. There are two valves that separate an atrium from a ventricle. This is on the right side, and we also have that on the left side. These types of valves are called atrioventricular valves. They separate an atrium and a ventricle. You'll be able to see these valves. The valves have specialized structures within the valves. You see these little sail-like structures? These are called cusps. There are cusps on each of these AV valves. That's AV is just short for atrioventricular. Attached to these are little rope-like structures. These are very strong, small. They're called chordae tendineae. And chordae is just a Latin name for rope. So they're like little tiny ropes. As you move down, these chordae tendineae are attached to a specialized structure called a papillary muscle. The papillary muscles control the opening and closing of the AV valves. Okay, and you can see there are papillary muscles here on the left side, also chordae tendineae and cusps. The cusps are different on each side. The AV valve on the right side has 3 cusps. We call it the tricuspid valve. On the left side, there are only 2 cusps. We call it the bicuspid valve. The bicuspid valve also has another name, the mitral valve. So if you hear mitral valve, you're looking at this one separating the left atrium and the left ventricle. You can see here the papillary muscles. Again, papillary muscles in a conjunction with the chordae tendineae here and the cusps open and close this valve, controlling the flow of blood from the atria into the ventricle. Now, each of these, you can also see the what are called semilunar valves. These are a little harder, and when you open it up, you'll probably have a hard time seeing them. We'll have to come down and look straight down these blood vessels to find those a bit, or make more cuts. All right. Other sections you can see here. On the outside, this is one of the layers of the heart. This is the epicardium. You have the big muscular layer, this on the model, the very red layer in here. This is the myocardium, and it is composed of cardiac muscle. It may be hard to see on this model, but you can see there's a slightly different color. This is epithelial tissue that lines the interior of the heart and also the blood vessels coming off. This is the endocardium. So those are the 3 layers. Endocardium lining the inside, the big thick myocardium, and then the outer capsule area is the epicardium. Okay. On the outside, you saw that sulcus between the 2 ventricles. Right below it is the interventricular septum. It's the wall that separates the 2 ventricles. And you can see it's a much thicker wall here. You will also see, it's a little hard to see on this model, but you can see there are some ridges in the ventricles. These are called trabeculae carni. They're just an upwelling of the underlying muscle tissue. It's not just straight, it just has ripples in it. There are also a similar structure in the atria that are really hard to see on the model. But you'll see very sharp ridges, especially in the auricles of the atria. And that's just the muscle. It's just organized slightly differently. And those in the atria, we call those the pectinate muscles there. Now, separating the ventricles, both the right and left, from the major blood vessel it's attached to, are these things called the semilunar valves. There's one here, and this one actually was used in a test and has a sticker on it, so we can remove that. And there's another one here. These do not need an extra muscle like the AV valves. They're just little flaps. These flaps move up against the wall of the blood vessel. When the ventricle relaxes, blood will start flowing backwards, but these flaps fill up with blood and spread out and block the entrance back into the heart. So they keep backflow from going back into the heart. And those are your semilunar valves. There are two semilunar valves, and they're just named for the blood vessel. This is called the pulmonary trunk. This is the pulmonary valve. This is the aorta that comes in through here. This is the aortic valve. And again, those are what we call semilunar valves, because in some ways you look at them, these flaps kind of look like half moon, so semilunar. Those are the structures you'll be looking at. When we get to the real hearts, we may dissect part of these blood vessels. You probably won't see all of these blood vessels. You'll see little stumps. We can look down and see the blood vessels and also look at the valves from the other side, maybe even pull apart and see the flaps coming away from the wall of the blood vessel. So that will need to have these cut off, and we'll be searching down that way. On the aorta, right past these on the aortic side, there are two small blood vessels coming out, and we can see one of them here. It looks like it's coming out of here, but it actually doesn't. It comes from here. These are the coronary arteries. So we have the right coronary artery and the left coronary artery. We saw them on the model here when they were out on the surface. So here we have the left coronary artery coming off, and we're putting the outside in again. We can see where it attaches and comes down. This is a branch of that left coronary artery. And then we can see on the right side coming through here, it runs down and runs down this direction. So here's your right coronary artery. Now, when we dissect the heart, we may be able to get something like this. This is a dental probe. We may be able to move down here, find the thing, and actually trace it down to the exterior of the heart. And we'll be able to see the tip of this probe as it moves into the exterior part of the heart. The one last thing we're going to want to do is to make a cut. No matter, your window's probably going to not come down this far, all the way across the bottom of the heart, taking in the apex. The reason to do that is you'll get a section with the width of the right ventricle wall and the width of the left ventricle wall. And by making a cut across here, it's really easy to compare the thickness of the walls. And you'll see that this thickness, you can see it in the model here, this thickness is much less than the wall here. And that just has to do with the amount of work they have to do. This ventricle only pumps to the lungs and back. This ventricle has to pump blood throughout the body, to the top of the head and down to the bottom of the toe. So it needs to do a lot more work. It needs more muscle power to do that, and that's why it has much thicker walls. And now we've gone through our dissection plan with the model. Now it's time to get the real sheep hearts.